Mars has always fascinated humans. Known as the Red Planet because of its reddish appearance, Mars has been a subject of scientific curiosity for centuries. It's one of the most studied planets in our solar system, and for good reason. Many scientists believe that Mars could hold clues to the origins of life beyond Earth. To uncover these secrets, NASA and other space agencies have launched a series of Mars Rover missions, sending robotic explorers to the surface of the Red Planet. The first successful Mars Rover mission was Sojourner, which landed in 1997 as part of NASA's Pathfinder mission. But the real breakthrough came with the later missions: Spirit, Opportunity, Curiosity, and most recently, Perseverance. These rovers have helped scientists explore Mars like never before, sending back images, data, and even soil samples from the Martian surface. Each rover has its own set of objectives, but the overarching goal of the Mars Rover missions is the same: to determine if Mars ever had conditions suitable for life. With their high-tech instruments, advanced cameras, and drilling tools, these rovers are our eyes and hands on Mars. They have explored the Martian surface, studied its geology, analyzed soil and rock samples, and looked for signs of past water. These missions have brought us closer to answering one of humanity's greatest questions: did life ever exist on Mars? The Mars rovers are not just exploring the Martian surface. They are the key to understanding the planet's geological history and its potential for supporting life. Over the years, each rover has provided incredible insights into the planet's atmosphere, surface, and internal composition. The Spirit and Opportunity rovers, which landed on Mars in 2004, were designed to last only 90 days. However, they both far exceeded their life expectancy, with Opportunity operating for nearly 15 years before losing contact in 2018. These rovers sent back crucial information about Mars' past climate, particularly the evidence of ancient water. Opportunity's discovery of the Meridiani Planum region, with its abundant hematite deposits, provided strong evidence that liquid water existed on Mars billions of years ago. The Curiosity rover, which landed in 2012, took things a step further. It has a more advanced suite of instruments and was tasked with investigating whether Mars could have supported microbial life in the past. Curiosity's discovery of ancient water streams in the Gale crater provided significant clues that Mars was once a much wetter planet. Finally, Perseverance, which landed in 2021, aims to find direct signs of ancient life. Its mission includes collecting samples of Martian soil and rock for a future return mission, with the hope that these samples will answer the critical question: was there ever life on Mars? Exploring Mars is no easy feat, and each Mars rover mission has faced a unique set of challenges. The Martian environment is extremely hostile, with freezing temperatures, dust storms, and radiation from the sun. The distance between Earth and Mars, about 225 million kilometers, means that communication signals take up to 20 minutes to travel one way. This time delay complicates the operation of the rovers, as scientists cannot control the rovers in real time. Instead, they send commands and then wait for the rover to execute them, often with no guarantee that everything will go according to plan. Another challenge is the terrain itself. Mars has rocky, uneven surfaces, and navigating through this landscape requires precision. The rovers need to be equipped with advanced tools, like cameras, drills, and robotic arms, to handle the Martian terrain and collect samples. Additionally, dust storms, some of which cover the entire planet, pose significant risks to the rovers, as they can block sunlight and damage solar panels. Despite these challenges, the rovers have performed remarkably well. Their longevity and the data they've provided far exceed the expectations of their engineers. Yet, the harsh environment of Mars means that the rovers' mission lives are finite. Each mission brings new lessons, paving the way for future exploration of the Red Planet. Each Mars rover mission has contributed to a growing body of knowledge about the Red Planet. One of the most significant discoveries was the evidence of water on Mars. The Spirit and Opportunity rovers found signs that liquid water once flowed across the Martian surface, carving valleys and creating mineral deposits. These findings suggest that Mars may have once had a climate capable of supporting life. Curiosity provided further evidence of ancient Martian lakes in the Gale crater. The discovery of organic molecules, such as methane, has sparked intense debate about the potential for life on Mars. These molecules are fundamental building blocks for life as we know it, and their presence suggests that Mars may have had the necessary ingredients for life billions of years ago. Perseverance has continued this search for signs of life. It is exploring the Jezero crater, which was once a lake, and it is collecting rock and soil samples to bring back to Earth. The rover's goal is to find traces of ancient microbial life, if it ever existed, and to study the planet's geology in greater detail. Perseverance is also testing new technologies, including a device that converts CO2 from the Martian atmosphere into oxygen, which could play a key role in future human exploration. These discoveries are reshaping our understanding of Mars and our search for life beyond Earth. Each new finding brings us one step closer to answering one of the most profound questions in science. Was Mars ever capable of supporting life? The Mars Rover missions have laid a strong foundation for future exploration of the Red Planet. But as successful as these missions have been, they are just the beginning. The next steps involve sending humans to Mars, and that's no small task. NASA's Artemis program, which aims to return humans to the Moon, is a stepping stone to achieving this goal. From the Moon, astronauts will learn how to live and work in space, preparing for the much longer journey to Mars. In the coming years, more advanced robotic missions will continue to explore Mars. NASA's Mars Sample Return mission, which will collect the samples gathered by Perseverance and bring them back to Earth, is already in the planning stages. Additionally, private companies like SpaceX are working towards developing the technology needed to send humans to Mars. The goal is not just to visit Mars, but to establish a long-term presence there. Scientists are working on technologies that could allow humans to live on Mars, such as building habitats, creating sustainable food sources, and developing life support systems. As we look to the future, Mars remains one of the most exciting frontiers in space exploration. The lessons we've learned from the Mars Rover missions will help guide humanity's journey to the Red Planet, one small step at a time.